Golf balls are said to be dimpled to reduce drag. If that's true, why aren't aeroplanes dimpled? Golf balls are dimpled to reduce drag because the dimples create tiny disturbances in the boundary layer of air flowing around the ball. The boundary layer is a thin layer of air that sticks to the surface of the ball and separates from the rest of the airflow at a certain point. The dimples on a golf ball disrupt the boundary layer, causing it to separate later and reducing the drag on the ball. Aeroplanes, on the other hand, have much larger scales and operate at much higher speeds than golf balls. At these larger scales and higher speeds, the dimples that work effectively on a golf ball would not have the same effect on an aeroplane. In addition, the surfaces of an aeroplane are designed with a specific shape and contour to reduce drag and increase lift. This is known as aerodynamic design. The shape and contour of the surfaces are carefully optimized through testing and analysis to achieve the desired performance characteristics. Overall, dimples on a golf ball can be an effective way to reduce drag at the small scales and low speeds at which golf balls operate, but they would not be practical or effective for use on an aeroplane. Many plastic materials are expected to last hundreds of years in a landfill. When it finally reaches a state where it's no longer plastic, what will be left? It is true that many types of plastic can take hundreds of years or more to break down in a landfill. This is because plastic is a synthetic material that is resistant to biodegradation, meaning it is not easily broken down by natural processes. When plastic is discarded in a landfill, it is typically not exposed to sunlight, water, and other factors that would facilitate the breakdown process. As a result, plastic can persist in the environment for a long time. However, it is important to note that plastic does not completely disappear or vanish over time. When plastic does break down in the environment, it can break down into smaller and smaller pieces, a process known as fragmentation. These smaller pieces of plastic are known as microplastics. Microplastics are typically less than 5 mm in size and can be found in a variety of environments, including oceans, rivers, and even the air we breathe. It is difficult to predict exactly what will be left of plastic after it has broken down in a landfill, as this will depend on the specific type of plastic and the conditions under which it degrades. However, it is likely that at least some small pieces of plastic will remain, even after the plastic has significantly broken down. Everyone knows that sharks can smell blood in the water. But are there any air-breathing animals that can smell underwater? Or water-breathing animals that can smell in the air? There are some air-breathing animals that have a sense of smell that allows them to detect substances in the water. For example, some species of birds, such as seabirds, have a keen sense of smell that they use to locate food in the water. For example, some species of albatross have been shown to be able to locate dead squid from several kilometers away by detecting the odors of the squid's volatile compounds. In addition, some marine mammals, such as dolphins and whales, have a sense of smell that is adapted for use in the water. These animals have a structure in their head called the olfactory bulb, which is responsible for processing smells. In dolphins and whales, the olfactory bulb is relatively small compared to those of land mammals, suggesting that their sense of smell is not as well developed as that of many land animals. However, they do have the ability to detect certain odors in the water, such as the scent of their prey. There are also water-breathing animals that have a sense of smell that is adapted for use in the air. For example, many species of fish have a well-developed sense of smell that they use to locate food, mates, and other important resources. Some species of fish, such as salmon and eels, are able to detect odors in the air when they are out of water. These fish have specialized structures in their head called nares, which are similar to nostrils in land animals and allow them to detect odors in the air. Overall, while not all air-breathing or water-breathing animals have a highly developed sense of smell, there are some species that do have the ability to detect odors in their respective environments.